number 33. In the given rectifier, the delay angle of the thyristor T1 measured from the positive going zero crossing of Vs is 30 degrees. If the input voltage Vs is 100 sine of 100 pi t volts, then the average voltage across R under steady state is dash. Okay. So in the beginning, let's write down what's given. We write down what is the equation given for input voltage. Now the input voltage is Vs and the expression is 100 sine 100 pi t. So that's given. Now in order to find out what the value of R is, we need to calculate first what V0 could be. So V0 average, we'll calculate the average output voltage. Now the average output voltage for such a circuit is written as 1 by 2 pi integral of 0 to 2 pi Vs d of omega t. So here is a formula that can be used quite often. Now since we have a rectifier, this equation applies here. V0 average equals to 1 by 2 pi integral of 0 to 2 pi Vs d omega t. Now let's substitute what Vs is. V0 average is equal to 1 by 2 pi into, now we are going to start by applying, now the question says that the delay angle is 30 degrees. So we start with 30 degrees here, pi by 6 to pi. Now the reason is because the source here is an alternating source. So we will have to take care of the positive half cycle and the negative half cycle as well. So we start with 30 degrees to pi. Vs is 100 sine of 100 pi t d omega t minus, now we have the rest of the cycle, pi to 2 pi, 100 sine 100 pi t d omega t. Okay. This is our quite a large expression, but we'll solve it. Okay. Now for the next part. This implies that 1 by 2 pi into, now in order to make it a little easier to write down all the steps, let's take the part which is inside the brackets. You see there's sine 100 pi t. Let's write 100 pi t as just omega t. That would make it a little simpler in order to write down the expression. So this is integral pi by 6 to pi 100 sine omega t. Okay, so I'm writing 100 pi t as omega t. So this is dt minus integral pi to 2 pi 100 sine omega t dt. Okay, next step. Let's integrate. So here 100, so integral of sine omega t is minus cos omega t at the limit of pi by 6 to pi minus 100. Again integral of sine will give us minus cos omega t at the limits of pi to 2 pi. Let's plug in the values of pi by 6 pi and here pi and 2 pi. We'll take 100 out common as well. So that's 100 divided by 2 pi into Now minus cos omega t, we have to substitute 30 and pi. We will arrive at 1 plus cos 30 plus, and two negatives will anyway make it plus, and then cos of pi and cos of 2 pi will give us 1 plus 1, right? And this will further give us 100 by 2 pi into 3 plus cos 30.866. Right. Let's further solve this. We will arrive at 100 divided by 2 pi into 3.866. And finally, to solve this, you will get a value of 61.56. So here, the question says that we have to find out the average voltage across R. In order to find out the average voltage across R, we use the average voltage formula of 1 by 2 pi integral of 0 to 2 pi Vs d omega t. So solving, we get the value of 61.56. This is the entire solution, and I hope it has helped.